Now let's imagine that we gave a survey out to our sample population and we collected their results. In the results, if it was a quantitative question asked, we got a lot of numerical answers back as a result. But looking at the collection of responses, we might not be able to draw inferences so well if we're not able to organize the responses. We need to organize the data in such a way that we can start to see the patterns. One way we can organize data is through frequency distributions. The goal of a frequency distribution is to tell us how often a particular data item repeats in the data set. So we will list the data values, x, and then next to it in a t-chart we'll list how many times they occur, which is their frequency, f. So for the data set I've drawn at the top of the screen, we have the values 1, 1, 2, 2, 2, 3, 4, and 4. And if we were to draw a frequency distribution of this data set, we would do so by making a t-chart. On the left side, you list the data items that occur. So the data items are 1, 2, 3, and 4. And then on the right side, you write their corresponding frequency. So we count how many times does 1 occur in our data set. 1 occurs 1, 2 times. So its corresponding frequency is 2. If we count 2 occurs 1, 2, 3 times, so its corresponding frequency is 3 times. Continuing this, we see 3 occurs once and 4 occurs twice. So this is our example of a frequency distribution. Next, we'll discuss the idea of relative frequency. So a relative frequency will describe the amount of times an item appears relative to the total number of items sampled. So we're going to take the frequency and then divide it by the total number of observations, and that's what takes our value n. So for our same example of the data set above, let's calculate its relative frequency distribution. So for the same data set, it will begin, always the relative frequency begins with just the plain frequency distribution, so we found that above. So I'm just going to recopy it here. 1 occurred 2 times in this data set. 2 occurred 1, 2, 3 times in the data set. 3 occurred once, and 4 occurred twice. Now what makes it the relative frequency is adding this third column where we have the frequency divided by the number of items surveyed. So let's see how many items were originally surveyed. We have 1, 2, 3, 4, 5, 6, 7, 8. So the original number of surveyed items was 8. So for each of these frequencies, I'm now going to take the fact that 1 occurred twice and say the relative frequency was 2/8. 2 occurred 3 times, the relative frequency of that was 3/8. The number of times 3 occurs is once out of the 8 options, and then the number of times 4 occurs is twice out of the 8 options. So this portion of the table that I've highlighted in pink is what makes this now a relative frequency distribution. Now in our next example, we are told that 15 members of a class were polled about the number of siblings in their individual families. We're then asked to construct a frequency distribution, so we'll do that first, and then a relative frequency distribution based on their responses. And we see the responses given here. So always when we're asked to construct a relative and a frequency distribution, we always go with the frequency distribution first, and we'll make our table. We always begin with x on the left, and those are our data set values. And let's look through the list. We see that we have a 1, 2, 3, 5, 4, and 6. So it looks like we have data values 1 through 6. So we'll make a table for each of those. And then to complete the frequency distribution, we then on the right side of the column have the f for the frequency, and let's count how many times each of these items occurred in the data set. The item 1 occurred 1, 2, 3, 4 times, so its frequency is 4. The item 2 occurred 1, 2, 3 times, so its frequency is 3. The item 3 occurred 1, 2, 3, 4, 5 times, so its frequency is 5. The item 4 occurred once, so its frequency is 1. The item 5 occurred once, so its frequency was 1 time. And finally, the item 6 also occurred 1 time, so its frequency is also 1. Now this so far completes our frequency distribution. In order to add to the relative frequency distribution, we can add one more column to this table. And in this column, we will head it with the title F divided by N. So that's the frequency for each data item divided by the total number. If we look back in the original phrase, we see the total number is 15 members. And we can find that as well if we count up each of the individual data items. So the relative frequency is that for the item 1, it occurs 4 out of 15 options. See that we're getting the 4, it's the frequency that the item 1 occurs. The 15 is coming from the idea that there are 15 data entries. So the relative frequency that item 2 occurs is it occurs 3 of the 15 times. The relative frequency of data set 3 is that it occurs 5 of the 15 times. And if you would, think about how you would answer for the relative frequency of data item 4, 5, and 6. The item 4 occurs 1 out of 15 times, as do 5 and 16. So with that, we have made our frequency distribution here, and then paired next to it, we have our relative frequency distribution. Now if we're given a data set and we'd like to organize the information that we just found in our frequency distribution, we could do so in a very nice way. And we might have seen this idea before as a bar chart. That's the idea of a histogram. So bar chart, histogram, same idea. And using the data from the previous example, our question to the 15 students about the number of siblings they had, we see it organized here. Let's create a histogram for this data. To begin, we create a horizontal and a vertical axis. And for the histogram, the vertical axis will always be the frequency that something occurs, and then the horizontal axis will always be whatever we're measuring. So in our last example, it was the number of siblings, so we'll label this number of siblings. And before we start creating our histogram, we need a frequency distribution. Now this is the exact same example as we just did, so let's copy down the frequency distribution that we found from our previous example. So from the data set, we would create our frequency distribution, which we can see on the left side of the screen, and then from that we make our histogram. So the way the histogram works is we glance through all the possible frequencies, and we see they can vary between numbers of the smallest 1 up to the highest of 5. So as we label on our vertical axes, we will choose values from 1 to 5. And then for the horizontal axes, we will look at our data set and see what are the different values that responded. And we see that students responded with digits 1 through 6, so that will be our horizontal axis. And then to complete the histogram, we give the bar chart aspect of it. So we see if we had one data item, the frequency was that it occurred 4 times. So we can show that with the bar chart where we go from 1 to about halfway between 1 and 2, and then our bar chart should rise to height 4. Next up is data item 2, and we see it occurred 3 times. So that would give us this portion of the bar chart. And we continue in this way throughout our entire frequency distribution. So for data item 3, it occurred 5 times. And then we see that data items 4, 5, and 6 all were of frequency 1. And that is how we can make our histogram based on our frequency distribution. So from this, we can quickly visualize and see that the data item 3 was the most frequently occurring data item. Specifically, it occurred 5 times. Data items 4, 5, and 6 were the least occurring responses, and they all occurred 1 time. Stem and leaf displays are ways to quickly organize the data values that we've been given so that we can at a glance see what are the data responses are and easily spot repetitions in the data. What you can see currently on the screen is an example of a stem and leaf display. Let's explain how we would read this. In a stem and leaf display, the digit to the left of the vertical line tells us the first digit of the number. So what I've highlighted here in blue is 1. That's telling me that everything in this row has a first digit of a 1. So the way I would read this is that this first item is a 1, 5, or 15. As I have another 5 coming after it, that means that there's a 15 that is repeated. And finally, the last digit on this row, the 8, means that I have a 1, 8, or 18. So this is the information that's encoded in our second row of the stem and leaf display, that our data have the values 15, 15, and 18. We can continue this with the rest of the values. So let's now look at the row starting with 2. In the row that starts with 2, this tells me that I have a 2 followed by a 0. That's representing the number 20. Next, we see we have a 2 followed by a 9. That's 29. Now that we've seen these first 2 examples, can you translate what the fourth row, the one starting with the 3, represents? That would be 36 followed by 37. Next, we have the row starting with a 4. It's telling us that we have the data points 42, 43, and 43 again. Now, you might be wondering, what about the top row? I intentionally skipped it so that we could first go over the pattern on values that are more clearly seen as 2-digit numbers. The first row is a little strange because what we want to gather here are actually all the numbers less than 10. So what is its, if we consider those as in the pattern of the 2-digit numbers, you would pretend there's a 0 in front of them. So this first row is communicating that we have a 1, a 2, and a 3. So these are the data items that were originally gathered from our survey, and to the left we can see them displayed in a stem and leaf display. Let's practice another example using stem and leaf displays. We recall the data given from our previous example where we had the hours spent studying. We had these 30 data points, and let's organize these using the stem and leaf display. So we always begin by saying, how many digits are there less than 10? Let's select those. And to represent those digits less than 10, we start with a 0 in our stem and leaf display, and let's list them from smallest to greatest. So we see 3, comma, I believe 4 is next, comma, 5, comma, 7, comma, and now we see 2 8s. I would want to copy it twice to show that there's repetition. And finally, 9. Now let's just glance over the 3 rows and make sure we didn't miss any data values less than 10. Okay, I think that's all. Next, let's look for the data values that are between 10 and less than 20. In other words, let's look for the data values that start with a 1. Let's record these values in our stem and leaf plot. So we record the values that are 2 digits that start with a 1. And let's try to record them in order. So looking at our orange ones, we see the lowest there is a 10, so I write 10, comma. The next lowest entry, I believe, is this 11, 11, comma. We have 2 12s, so I'll record the 2 twice. Then a 13. Then 2 14s. Record the 4 twice. 2 16s. And finally, an 18. Next, in our stem and leaf display, let's record those data values that are 2 digits and start with a 2. So those 2-digit numbers that start with a 2, in order, the lowest one we have is a 20, so we record 20, comma. Next, I think we have 22, and we're recording its second digit. Then we have 224, so we'll record the second digit of 4 on the 2 row. Then a 25, a 26, and finally a 27. Next, let's include those 2-digit numbers that start with a 3. We have 2 31s, so we record the 1 in the 3 row twice. Then we have a 33, and then we have a 35. Next up, let's include those 2-digit numbers that start with a 4. We see that those are 42 and 40. So as we label those, we will get 40 and 42. So this is our stem and leaf display organized from the 30 data entries we see above. So to practice working with the stem and leaf display, can you find the number 25 in the stem and leaf display? Visualize where that would be on the screen. The 25 is found in the row that starts with a 2, and then it is seen 5 places over on the digit 5, so 25.